In this video, I'm going to be showing you how to solve a three-variable system using Gaussian elimination. Now, what I'm going to teach you is just a method that's going to work every single time, regardless of what your x, y, and z values are, and regardless of what these coefficients over here are, okay? You're going to realize as you start to work with three-variable systems that maybe there are quicker ways to do it. But I'm going to show you a method that works every single time. Step one, you want to combine, I need to label my three equations, equations 1, 2, and 3. And the only reason I'm doing that is so I can talk about equations 1 and 3 and things like that. And you'll know what I mean. Step one, you want to then combine 1 and 2, and you want to get rid of the x using elimination. So basically what I mean is that I want to take x plus y plus z is equal to 0, and equation 2, which is 2x minus 2y plus 3z is equal to 13, and I want to take and get rid of the x using elimination, which means that I need to multiply the top by -2. Now if I do that, then that gives me a -2x minus 2y minus 2z is equal to 0, and I re-record the second equation. And if I add those up, these go away, I'm left with -4y plus z is equal to 13. Step one down. Okay, we're going to save this. In fact, we're going to call this equation 4 here. Next step, I need to then combine 1 and 3. And once again, this is the biggest portion of this. I need to get rid of the x. The big idea is that I get rid of the same variable both times. As you get better at working with matrices, you realize that maybe it's easier to eliminate the y first or the z first. But as long as you do the same variable both times, you should be fine. If I combine then equations 1 and 3, I see I have x plus y plus z is equal to 0, and I have -5x minus y minus z is equal to -8. It looks like I need to multiply the top one by -5 to get rid of the x. So I have -5x minus 5y minus 5z is equal to 0. -5x, whoops, I need to make that a positive 5. What am I doing? 5x plus 5y plus 5z is equal to 0. -5x minus y minus z is equal to -8. I add these up. They go away like I wanted them to. I end up with 4y plus 4z is equal to -8. We're going to call this equation 5. Now, look what you've done. You've created two equations right here that have only a y and a z in them. So my third step then, and this is the third step every time, I'm going to combine equations 4 and 5 and get rid of the y. So, lights. Nothing like having lights on a timer. If I combine equations 4 and 5, that means that I have -4y, this is equation 4 and equation 5. -4y plus z is equal to 13. 4y plus 4z is equal to -8. And looky there, I can just straight add them up. I get 5z is equal to 13 minus h, which is 5. So z must be 1. So I've solved one of them. Now I can go back and I can plug into either equation 4 or 5. Let's say 4. I know that -4y plus z is equal to 13. So -4y plus 1 is equal to 13 now. That means if I subtract 1 from both sides, that -4y is going to be equal to 12. And y must be -3. So now I'm almost done. I've got I've got y and z solved for. Now I just need to go back to x. Easiest equation might be just equation number 1, and I know that x plus y plus z is equal to 0 as long as I go back to one of the original equations. It doesn't matter which one. But I know then that means that x minus 3 plus 1 equals 0. That is x minus 2 is equal to 0, so x must equal 2. So my final answer, if you need to put it in x, y, z coordinates, should be 2, -3, 1.